Hello diddly do, my dear viewers. Today we're here with a 4Q kata, you know? There's some hardcore stuff going on around here. We're getting out of our comfort zone. It's called regular expressions groups, splitting phone numbers into their separate parts. As you can see, there are regular expressions in the tag by algorithms, declarative programming, advanced language features, fundamentals, and strings. Let's read it. With regular expressions, you can find information and even split the found information into parts. This will be a recognition test, although it is important to know how regular expression groups work. The assignment will be to create a regular expression that will match Dutch with Dutch phone numbers. Alright, we know how to do that. These phone numbers can be written multiple ways. So, this is how you dial a number in another nation. This is a more readable, shorter version. So from here on everything is the same, just 00 turns to plus. This is how you would dial number in the same nation. So everything, this or this just turns to 0. And this is how you would dial a number in the same area. So 343434 disappears and nothing is replaced. These phone numbers can be split up into a nation code without prefix. Alright, so this is the nation code. An area code is just this, and the local number. The regular expression should only contain these three code groups, and anything in a format other than shown in the examples above should not result in a match. Especially consider these additional rules. The nation code, area code, and local number may never contain a 0 at the start. A nation code, unless it is the prefix for dialing out for dialing out of the country, or it is at the beginning of the area code. Beginning of the area code right here, I think, like this, if there is no country code. Alright, some example of invalid codes because of this rule. Alright, I understand this. There should be alright. Okay. It's because of this. It's because of this. It's because of this. This is because of both of these. Because of this. Good luck. Yeah, I'll need it. Because this, like, I don't quite understand fully this part of the kata. Alright. The validation test will display the number with which it fails, but not the details. Do not hesitate to add your own example tests. Wow, a challenge. Nice. I love test-driven development. Alright. Wow, what a confusing test. regex string. Fix me. So, up until now in each kata we define the function. In this one we just write a regex, regular expression string, which is much more simpler. Now we don't need to like do the re compile, think about that, and do a match function, and then do something with the match object. Just this is not none. Alright. They also okay. So if we test it out, what happens? Couldn't match the number. Alright, so if we just write the test, I mean this regular expression, Let's first make it a raw string, so there won't be no like funny stuff with the characters. Then, as I can understand, there are 3 groups. This is the last one, this is the middle one, this is the first one. And the first one and the second are not necessary. And the first one has to be 0, 0 followed by a digit and a digit, or plus followed by digit and digit. Now the problem is that maybe the regular expression mistakes this plus as a character that is allowed to for something like something like the not the operator, like the alright, let's check out the regex is this operator or just regex python how to. Here of meta characters, yeah. We don't want this to be mistaken for a meta character, just for an ordinary character. So, alright, this is equivalent to the class. Now, if that is equivalent to that one, then we should have changed this into not 0 to 9, because this is basically of equivalent what just was, but to 1 to 9. Because of this example, look, this is not correct. And also, this should not be 0, never, so we say 1 to 9. And let us see how to take care of that. Regex escape meta characters. Did I? Alright. Here meta characters are explained. We're looking at this one. Okay. Quantifiers to indicate the scope of a search string. You can use multiple quantifiers in your search string. The following table gives examples of the quantifiers you can use in your regular expressions. Oh, okay, we can use a quantifier. Alright, that's a smart way. We can just say like a number 0 to 5 can occur 2 times. Again, number 0 to 5 can occur 2 times. And or matches when the preceding character or character group occurs at least n times, and at most m times. Alright, nice one. Escaping the characters. Yeah, this is exactly for the for the phone number stuff, you know. So we just use, I guess, this character. Alright. And this is the first group. Now the second group is the so-called area code, and it can look like this, it can look like this. An area code with 2 digits with the leading if it's at the beginning of the whole number and the local number. Alright, so the area code can look like, if I'm not mistaken, 0 to 9 2 times, or or no, I'll just write it away. So 9 2 times, or 0 and then 1 to 9 2 times. Now, if it happened, this example can only happen if there is no first group. So a test will possibly give us a red unpass sign, because it will, because this string will let through such instances when first group is full and the second one looks like this, but we shall see that. So the last one is how many numbers? 6, right? Just 6. 1, 2, 3, 4, 5, 6. Alright, and this is just like first is just 0 to 9, and then it's a digit for 5 more times. Let's test it out. Couldn't match the number. Now, it could not match the number. Maybe we need to this group can be 1 or none times, or 1 or multiple times. I forgot what's the difference between a star and a plus meta character. Like, plus sign is it marks it's 1 or more, and the star is what? None or more. And the backslash plague. Okay, group start, span, iterator, SC, multiline. Grouping, queried grouping. Lookahead. Lookahead. Oh, okay. Some interesting stuff. Common problems, match versus search. So this is just how to. Looking at how to. Previous socket programming. Oh my god, this is for my project. Nice. I'll check that later. But we can just look up the meta character over here. So this is when the character preceding matches 0 or more times, and this is 1 or more times. Alright. So we say, let's just do a plus in the end, and let's run the test. Couldn't match the number. Could not match the number. Why couldn't it match the number? Did I use the wrong slash over here? It's from left to right. So it's also from left to right. So let's do it. Let's read it. So or this. So we say plus, then 2 times a number from 1 to 9. Okay, this should pass. Oh my god, I didn't account for I haven't accounted for spaces, for empty spaces. Maybe if I just like put an, or just check over here, empty space, period, plus, star, character set, symbol, alphanumeric character, the whole number. Okay. Space, white space. Maybe check out the first occurrence. Let's see, matches any white space character. Alright, so let's just say /s over here. /s /s okay. I know that sounds funny. /s and /s. Alright, let's test it out. Yeah, we got the first green test. Nice. Nice. Oh, wow. Alright. This is how the test wants it. Couldn't match group 1 for the plus 12 should equal just 12. Alright. So let us then look. I mean, what's wrong over here? For sure the white spaces are the problem. So let's just say we remove these 2 white spaces from the second group and put the white space over oh my god. Yeah, white space over here and test this thing out. Now we got 2 tests passing. Alright, we then move these 2 white spaces again outside of the group. Oh, did I make 2 screenshots? Yeah, 3 screenshots, 4. Alright, 5 I guess. S question mark. We tested out, it will still be red. At least the white space isn't over there, and the plus sign should be outside of the group. So is there a operator that excludes the, or maybe we could just do it like this, like before group we again /plus and it could occur 0. Alright. Matching test for ABCD. Alright, let's attempt it. Alright. A few hints if needed. Anti-cheat tests. Yo, what the hell? Test passed. How could I cheat? A few hints. Number used 0090705000 should be. Your matching results are none. Should be. Alright. So the thing is that my second group over here doesn't accept 0 as a second integer. So let's say the first integer must be non-zero, but the second can be any number you like. And why is this 2 doing over here? Did I put it over there by mistake? No? Alright. What a funny thing. What a funny thing. D. And to this also again. Like I had a bug in my code and it passed the test. Let's make an attempt again. Or maybe we should just at first test it against. Alright. Put a question mark over here. Attempt. Alright, attempt. Number used. Your matching results, none. So I guess if m is not none, then do that. Couldn't match the number. Put your own test cases below. Like below where? Like I guess over here. Alright. So let's make a test. So we won't have to press the attempt button all the time. And let us say the test is 0 0 3 0 7 8 0 7 1 2 3 4 5. Alright, let's test this, and this should and this one cancel. And this so we're looking at groups, and the first group should be 0 0 3 0, and the second group should be 8 0, and the third group should be 5 6 7 8 9 0 5. What am I looking at? I'm looking at this. What a bamboozle. 1 2 3 4 5, and then we say true. It should match. Let's test it. Not enough values to unpack. Expected 3. Got 2. Oh, yoy. What am I doing? What am I doing? Test. Alright. So I wrote the test for that. Okay. Now. Couldn't match the number. It should go. Yeah. It is because of this one also. Just like I corrected this part, this group, which has become this group, I also need to repair this one, because this accepts only stuff from 1 to 9 and it's second place. I shall repair it so it accepts any integer in its second place. Alright, green. Maybe, yeah, I won't, okay, I'm not even looking. So, let us write a test that will, never mind. Never mind, we could do this all day. Couldn't match test for group. 0090 shouldn't match the number. Yeah. I planned to write the test for something like that, for the example where it shouldn't have matched the number. So we'll say couldn't match group 1. 0090 should equal, so a few hints if needed. Are we looking at the same example again? Oh, so this should be like this. And what if we just put 00 and a question mark over here? We fix that and we fix our first test. Oh, so then we need a group. Alright. This is getting kind of spaghetti like, you know. And this weird stuff over here. So now we just fail one test, and it is the one that if there is this in the beginning, then this 0 shouldn't be here. And and that could be just solved by another question mark. 0 and a question mark. So it can be or it cannot be. Test it out. Attempt. It will still match. Yeah, I should have known it even before running the tests. Question mark. So this 0 is the problem. Without, I mean, if this 0 is here outside, then the OR statement makes no use in this group. The thing is that if, and also this group are exactly the same now that I see it. So we can delete the OR. And yeah, what a funny thing, right? And the thing is that if everything over here is 1, then this part of the OR of the group should be invalid. And I think there is a solution to that. It's like a logic in the regular expressions, because I saw that over here. Performing matches, not at performing matches. Model level functions, compilation flags, more pattern, more meta characters, alternation, or the OR operator, matches at the beginning of lines, matches at the end of a line, matches only the start of the string, matches only end of the string, word boundary. Okay. Grouping. That's what we're doing. Groups. Non-capturing and named groups. Alright, let's rest our eyes for these 15 seconds. We're really looking at the screen very intensely, trying to solve this problem. Okay, and drink some water. So, non-capturing named groups. Elaborate regular expressions. I don't even know what elaborate means. Elaborate. Elaborate. Planned or executed with painstaking attention to numerous parts of details. Alright, so elaborate regular expressions may use many groups, both to capture substrings of interest and to group and structure the regular expression itself. In complex regular expressions, it becomes difficult to keep track of the group numbers. There are two features which help with this problem. Both of them use a common syntax for regular expression extensions, so we'll look at it first. Perl 5 is well known for its powerful additions to standard regular expressions. For these new features, the Perl developers couldn't choose new single keystroke meta characters or new special sequences beginning with slash, without making Perl's regular expressions confusingly different from standard regular expressions. If they chose at as a new meta character, for example, all the expressions would be assuming that at was a regular character and wouldn't have escaped it by writing slash and or this. The solution chosen by the Perl developers was to use question mark ... as the extension syntax. Question mark immediately after a parenthesis was a syntax error, because the question mark would have nothing to repeat, so this didn't introduce any compatibility problems. Smart. The characters immediately after the question mark indicate what extension is being used, so question mark equals full is one thing, a positive lookahead assertion, yeah, these things, and divided full is something else, a non-capturing group containing the sub-expression of full. Python supports several of Perl's extensions and adds an extension syntax to Perl's extension syntax. If the first character after the question mark is a P, you know that is an extension that is specific to Python. Aha. Okay. Now that we've looked at the general expression syntax, extension syntax, we can return to the features that simplify working with groups in complex regular expressions. Sometimes you'll want to use a group to denote a part of the regular expression but aren't interested in retrieving the group's contents. You can make this fact explicit by using a non-capturing group, question mark divided, where you can replace the three dots with any other regular expression. Now my question is, shouldn't be question mark over here is a P. Specific to Python, okay. Okay, so groups, okay, so this is a this group doesn't get registered. That's a useful piece of information, but can it help us? I don't think so. Maybe if you're a really smart viewer right now, you're thinking, oh, I know, I personally don't know why. Group match of non-capturing groups is exactly the same capturing group. Replace it and name is obviously the name of the group. Obviously. Mm-hmm. All right. Okay. Anything and anything in the end. Now, I might pause this our comfortable reading of the documentation to go to the toilet. So, see you in a bit in part 2. We'll continue searching for a way to make some logic, like right over here, to say, wow, if, for example, if this over here, yeah, because right now, all right, first let's just incorporate what we have learned from this. So we say we make this into a group. We make this into a, how do you call it professionally? You call it non-capturing group. So you put a question mark over here, question mark back here, and it can be 0, 0 or escaped plus. We just test if this still runs, and it doesn't run. Unknown extension 0 at position 1. Alright, that's a conflict that should work. Huh? Ah, okay. Okay, we need to also put this thing over here, run the test. Alright, we've learned something. Now this is a little bit more organized, if you ask me. And we... Alright. Now the next thing is, as you see, we must say if this, like if this thing is 1 and not 0, then only this part of the second group is valid. If this, then it shouldn't match. So we'll figure it out in part 2. Now I go to the toilet. Bye!